Okay, we'll begin the class. All are able to hear me or no?
Yes, ma'am.
Okay, good morning. Okay, today we'll continue up the earlier class. So we'll learn out again what is self-inductance, mutual inductance, what is self-induced EMF, mutual induced EMF, how you can separate out the principle of a motor and a generator based upon the equations we will discuss today. Right, there is a diagram that I'm showing. All are able to check it out, I think so. So what arrangement does that represent, that figure?
South Pole,
Dynamic
North Pole.
induced EMF.
So you are having a magnetic field here that is being generated by this north and south pole magnets. The flux lines are running here, all right, in between them, and you are using a coil here like a conductor, and the length of the conductor is L. Okay, L is the length of the conductor, L meter, and you are setting this into rotation. Thereby, it is cutting the flux lines and is generating the flux density, which is given by V Weber per meter square. And it is rotating and making a right angle to the field, they say. So while it is made rotational, it will move to a small distance. Let that small distance be dx, and that movement of that coil takes place in dt seconds. Okay, so this is the circuit arrangement that you have set up, based upon which you are going to derive one expression for EMF. All right, you know that already as per Faraday's law of electromagnetic induction, there is an equation for EMF which is given by what formula?
D phi by D minus N into D phi by D.
N into. Okay. Another formula also you are going to develop, that will be the principle of operation of a generator, that is based upon this arrangement only. Again, I am telling you there is a field that is being set up by the north and south pole magnets, in which you are keeping a coil of length L moved in right angles. While it is moving, it is making a displacement of dx at time dt, and it produces a flux density of V. Okay. Now the area that is swept by the conductor when it's made to rotate is given by L into dx. Okay, that is the area that is swept by the conductor. It is kept into rotation. So the area that is swept by it is given by that length into the displacement that is moved by the conductor. So just now we have found out the area. Now how much flux is cut when it is rotating in that is given by what formula? You know what is the formula for phi? You know, in terms of B and A. What is the formula?
B dot
Phi
D.
equal to
B into A. So what is the formula for A that you have just now found out? That is BL into dx.
LDX.
Okay, so this is the flux that is cut by the conductor. Now we are going to derive the formula for E. So what is the formula for E? As per Faraday's law of electromagnetic induction,
D
minus
phi by dt.
N into
Minus N
d
into D
phi
phi by
by
dt.
dt. Okay, so in place of phi, you are going to substitute BL dx. So if you are substituting, then what will be the answer that you will be getting? E will be equivalent to N into d by dt BL dx.
B constant.
Okay, so in this case, B is a constant, L is a constant, so you can take all the parameter out, and assuming N is equal to 1, BL
Velocity.
dx divided by dt. Okay, so this is my rate of change of displacement. So it is equivalent to
Yes,
what
ma'am.
parameter?
Velocity.
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 So you can replace that V, L, V. Alright. So this is the equation for induced EMF in another way. And suppose if you are assuming this coil is making a movement which is making an angle of theta degree. Okay, it is rotating. While it is rotating, it makes an angle of theta degree, you assume. then the formula will be undergoing a little change. In that case, E will be equivalent to BLV sin theta volt.
Hmm.
Okay, so this formula you remember. What is the other formula for EMF induced?
BLV sin theta. B bar dot L bar into
BLV sin theta. Okay.
When the
So
coil is moving
this is actually,
or rotating,
then how will you be able to generate an EMF?
means
Moving means rotational mechanism only.
okay.
Okay, it is rotating like this, thereby making a movement. Okay. So this is how a generator works, and it produces what type of EMF? Dynamically or statically? Dynamically induced EMF.
dynamically
So
Dynamic.
what is the
Dynamic.
final equation that you are having? BLV sin
sin
theta.
theta.
Okay,
Sin theta.
where L is the length, V is the velocity, V is the flux density, and the theta is the angle that is made by the rotation of the coil. Okay, in the field. Now, one more thing you are doing here. Here to the coil you are feeding the current. Then it will become
Can you
the
repeat that?
operating principle of what machine? Earlier, you were not passing current through the coil. It was just kept rotational. Trying to do is you are going to pass current now through the coil,
Motor.
and it is not yet rotational. Okay, it is stationary initially. So what will happen? This is working principle of what machine?
Motor, motor.
Motor, ma'am.
Motor. Okay, motor. So for motor also there will be some EMF induced, and there will be a force and a torque, as I told you in earlier class. Here, for the generator, you have derived the expression for E. Okay, generator BLV sin theta is the equation that is for a generating machine. Now we are turning that into a motoring machine. So we will discuss what is the equation of a force in that case. So this is how you are passing current through the coil, and it is not yet stationary. In this case, there will be a force that is experienced by the conductor, twisting force. Because of the twisting force only, it is set into rotation. Already we have discussed all those things. Again, the same setup. There is a magnetic field which is having a flux density of V. The conductor length is L, and current I is passed through the coil. So the resultant of which a force is experienced by the conductor, that is given by what formula?
Ma'am,
BLI.
Yes, BIL. Okay, so this is how the motoring principle works out. Okay, you are having a coil here in the magnetic field, and the coil is being passed with the current I. The length of the conductor is L. Okay, and it is producing again a magnetic flux density of V. So as a resultant of which it will experience a force, twisting force, which is given by what formula?
BIL.
BIL.
L.
And again, because of this force, it will be set into rotation. Earlier, in the initial case, it was not rotating. Now, because of this theta, so if this is the case, then what will be the formula for force?
BLI square.
BIL.
So this is the force
Sin
equation.
theta. Sin theta.
Okay, that is for motoring machine or generating machine.
Motor.
Motor. Okay, so that is the difference between the working principle of a generator and motor. If it is generator, means what is the equation for EMF?
BVL sin theta.
BLV sin theta.
BLV sin theta.
BLV sin theta. Yeah, because output for a generator is electrical energy, so electrical EMF. Suppose if it is working as a motor, then the output is mechanical energy, so that is given by VIL sin theta. Newton. Okay. Next we'll move on to self-inductance. Okay. How to derive an equation for self-inductance, you have to discuss. So for that, they have given one definition. How can you define the self-inductance? There's a definition that is given in the slide now. So how can you do the
The
definition?
rate of change of flux linkages with respect to the current
Self-inductance
in it.
equal to d phi by dt. d phi by di.
d phi by di. So phi is flux, psi is flux linkage. Okay, phi is flux, while phi is flux, psi is flux linkage. Okay, this flux linkage is given by n into phi. You usually have n number of turns here wound around that bar of iron or a magnetic specimen. So how much flux is linking with the number of turns is given by what formula? N into phi, that is called as what? Psi. Psi represents what?
Flux linkage.
Flux linkage. Okay, psi represents flux linkage, phi represents flux. So if you assume an arrangement of a magnetic field is like this. Okay, you are having a magnetic specimen here around which you are having considerable number of turns of coil in the form of a conductor wound around. You are supplying it, passing current I, which will magnetize this specimen. Okay, so in such a condition, if I want to define the parameters, that is self-inductance, it is nothing but rate of change of flux linkage with respect to current. So how can I do the equation for L? So flux linkage is psi. So rate of change of flux linkage with respect to I. So that is how I will be defining self-inductance. Now I know what to substitute for psi. So what value will I substitute for psi?
N d phi.
N d phi.
L into di.
Yes, N d phi I will substitute. So same thing I am doing here. D by dt into N phi. Okay. Now between these two, which is constant? N or phi?
N, ma'am.
N is fixed number of turns. So I can take it out. So I will be getting N d phi divided by I. This is I actually, not phi, I. Okay. Now this is how I will be writing one equation for self-inductance. Okay. So N into d phi by dt, the unit is Henry. Okay, N into d phi by di, the unit is Henry. Alright. Now I have to elaborate this formula. I am having one more formula for L. But remember, this is one formula for L. What is the formula? N into d phi by di, or simply d psi by di. Okay, N into d phi by di or d psi by di. The unit is Henry. Okay. Now going back to the magnetic field principle. Now you know what is H. What is H?
Magnetizing force.
Formula
Li.
Ni divided by L. Okay, what is the formula for B?
Phi by A.
Phi by
Mu naught mu r H. Okay. Now mu naught mu r H is Ni divided by L. Okay. Now I want to write phi. So what is phi?
Flux density.
Formula
BA.
BA. So B is given by mu naught mu r Ni divided by L into A. Okay, this is my flux formula. Okay, now I want to find out inductance. Given by what formula? Just now I have told you what is the formula for L. What is the formula for L?
N into d phi by di.
N into d phi by dt di. Okay, so in place of phi, I can substitute the above formula. So if I substitute it, what will I get? I will rub this a little bit. Okay. So what will be the equation? L is equal to
N square mu naught.
No, ma'am.
N
d
square
by dt mu naught mu r Ni L A. Okay,
Yes, ma'am.
this is again I not dt. Okay, so now again in this formula, what are the constants? Mu naught is a constant, mu L is a constant, number of turns is a constant. Okay, L is a constant, A is a constant. So you take all the things out of the equation. Okay, so n squared mu naught mu r, okay, and A divided by L. Now di by di. So this I and I will get cancelled. Now what is the final formula for L? Tell me. L is equal to
n
n
square
squared.
mu naught
Okay.
mu r
Uh,
a divided by l.
the remaining things I will take it as in the denominator. Mu naught mu or A. I will take it to the denominator. So this is equivalent to what?
Yes, ma'am. Reluctance.
Reluctance. So L will be equivalent to n squared by S. Henry. This is another formula that we are having for what parameter?
Self-inductance.
Inductance. Self-inductance.
Inductance, self-inductance. Okay, remember this formula, make a note. Okay, this will be useful for solving problem. Both L is equal to N into d phi by dt, d psi by di, and N square divided by S. Have you made a note of the formula? This formula, sometimes they will ask you to derive, write short notes on derivation of self-inductance, so you should know how to derive. Have you understood this part?
Yes, ma'am.
So what is the formula for self-inductance?
N square mu naught mu r A by L.
Simply n squared by s,
Yes.
where s is representing your reluctance. Reluctance formula is what? L divided by mu naught mu r. N represents the number of turns. Okay. Next thing is you have determined self-inductance. Okay. Now you need to determine self-induced EMF. So I told you what is self-induced EMF, how it differs from mutually induced EMF. So tell me, what do you mean by self-induced EMF?
Ma'am, it is the EMF created by its own current.
Yes, here only one coil is present. Because of the current that is passing through this coil, the flux will be produced, because of which an EMF will be generated. That EMF is called as what EMF? Self-induced EMF. Okay, given by E, that you need to derive. Okay, one more formula for self-induced EMF. Okay, self-induced EMF you have to derive now. Okay, now you know what is the formula for E as per Faraday's law of electromagnetic induction, that is N d phi by dt. Okay, in this formula you add and you multiply and divide on di. Okay, will that be changing the original equation or not?
Yes, ma'am.
Will it change? Don't change the original equation, because I am multiplying and dividing the same parameter. So I am rewriting the equation in a different way. Di by dt. Okay. Now I know what this is equivalent to. What does n d phi by di equal? What are the various formula for inductance, self-inductance? Just now we have learned out. Know what are the two formulae?
L, yes ma'am,
N into d phi by di.
One formula is n squared by s. Another formula is n into d phi by di. So this
dt.
can be replaced as what parameter?
N into d phi by dt.
Yes, L into d phi by dt. This is my L. So E will be equal to L into di by dt. Okay, this is the formula for what EMF? What is the name of the EMF?
Self-induced EMF.
Self-induced EMF. Okay, self-induced EMF. Okay, this is how we will be deriving the equation for self-induced EMF. E is equal to L into di by dt. Make a note of this formula also. While solving problem, we will need it. Have you made a note? All the others in class, are you copying down the formula that I am telling
Yes,
you?
ma'am.
Important.
Yes, ma'am.
Yes, ma'am.
Ma'am,
Yes,
also
ma'am.
to copy
Yes,
the
ma'am.
derivation, ma'am, or
Derivation
just
is
the
also
formula?
important. Okay.
Okay, ma'am.
While I'm telling you, it should have taken down. Anyways, so this is L formula inspired by us, and this is the formula for E, that is self-induced EMF L into di by dt. Okay. Next comes your mutual inductance formula. Okay, mutual inductance you need to derive on similar equation. So in order to define the concept mutual inductance, you have to have how many coils?
Two, ma'am.
Two coils.
One.
Okay.
True.
So the setup shows here two coil arrangement. Okay. Primary coil and secondary coil, and in the second for the primary coil you are having a current flow I1, because of which a flux will be set up. Let that flux be 511. Okay, but it will not be linking with only primary coil. As you can see, this is the flux that is linking with the primary coil partially, but most of the coil is also linking with what? Most of the flux is partially linking with the secondary coil. Okay. So because of this 511 linking with the secondary coil, you will have some EMF induced here. That EMF is called as what EMF?
Actually, ma'am.
Mutually induced EMF. And based upon that, you will have M factor. M is representing what?
Mutual inductance.
Mutual inductance. Okay. Similarly, because of this current I2, there will be some flux that is produced. Let that flux be 2,2. The flux will be linking not only with this coil, it will be also linking with the primary coil. Okay, because of which there will be a mutual inductance existing between these two coils, and here also you will have mutually induced EMF. Okay, so you need to derive again some equations for coefficient of coupling, mutual inductance, and mutually induced EMF. Okay. Now K represents your coefficient of coupling. Okay, coefficient of coupling, that is given by what factor? K. Okay. K will be always less than 1. Okay, less than or equal to 1. Okay. Suppose if K is equal to 0, so assume the first case where K takes the value of 0, then that means these two coils are very far. Okay, very far, and the magnetic coupling, what can you say about the magnetic coupling if K is equal to 0?
There will be no coupling then.
Weak, very weak coupling. Okay, very weak coupling. These two coils will be very, very far off if K is equal to 0, and there will be a weak coupling existing between these two coils. Okay, second case is, suppose if K is equal to 1 exactly. Okay,
Very
that
near.
means in the same core, this is the core, let us consider this is the primary coil. The secondary coil will also be in the same core. Okay, secondary coil, primary coil, and secondary coil both are wound on the same core or same limb. If this is the case, they are closely placed. So there will be a strong magnetic coupling between this primary and the secondary coil. That is the case when K takes what value?
1.
1. Okay. But majorly K will be less than or equal to 1, 1. Okay, so this is called as what factor?
Coupling.
Coefficient of coupling. So depending upon the value that the coefficient of coupling takes, you will be having either strong coupling or weak magnetic coupling, and the spacing of the coils will also be varying accordingly. Okay, and there is a formula that is given for this coefficient of coupling. You can see for yourselves. What is the formula that is given for coefficient of coupling? wait till the page loads. I think you are not now it is loaded. No, so what is the formula for coefficient of coupling?
Phi F2 upon phi F1.
Yes. So what is the difference between 511, 521? 511 is because of its own current or
Yes, ma'am. So one current, one current.
one current. What about
Primary.
521 means?
It is due to another current.
Yes, it is because of the other coil current.
Yes,
Okay.
ma'am.
So this is how you will be writing down coefficient of coupling formula, ratio of the flux. Okay. Now we are to write down one formula for mutual inductance. Now there are two mutual inductance involved because you are having two coils. One is M12 and the other one is M21.
2-1.
Okay, this M12 is the mutual inductance in the first coil because of the secondary current. M21 is a mutual inductance in the secondary coil because of the primary current. Okay, and the equation you know, okay, that is the rate of change of flux linkage, that is N into d phi by di.
Yeah,
That equation only we are writing here. So this I have told you that this is the mutual inductance present in first coil because of the current I2. So the number of turns is N1, but the current here is what?
I2, ma'am.
I2.
Okay, and the flux that is linked is the
One.
flux that is
1, 2.
linked in one first coil because of the secondary current. Okay, but what about this equation M21? That
Ma'am,
is
it
a
is
mutual
plus due to
inductance.
first current.
It will be
Current in first.
N2 into because of the current primary current in the secondary coil. Okay, so we have finished off writing the equations for mutual inductance. As per sustainability of energy criteria, both M1 and M2 will be equal. Okay, M1 and 2 will be equivalent to M21. Based upon this assumption, if I want to multiply M12, M21, okay, that will be M squared. So I am going to multiply this M squared only. So you already know the formula for M12, M21, these two. I am substituting here. Okay. Now one more simplification I can do based upon the coefficient of coupling formula. Okay, so what is the coefficient of coupling formula? This formula.
Phi 2 of 1 by phi of 1
Yes.
of.
So based upon this formula, what is my phi 11 or phi 21? Here I am having phi 12. Here I am having phi 21. So phi 21 is equivalent to what? Phi 21 is equivalent to, based upon this formula, k into phi 11. Similarly, phi 12 is equal to k into phi 22. I am just cross multiplying. So these values I am substituting in place of phi 12, phi 21 here. Okay. So m squared will be finally equivalent to n1, n2, k d phi 22 divided by di2, then k d phi 11 divided by di1. Okay. This formula. Alright. Now finally I have to simplify this. So n1, n2, k squared. Okay. I am grouping up the terms. I am grouping this n1 with this one and n2 with this one. Okay. So what will happen? I am grouping this like this. So these two can be written like what? You know the
M1
formula
and
for self-inductance. What is the formula for self-inductance? N into
N into
d
d
phi by
by di.
dt. So di. Okay, di. So if you closely observe this equation, this is 1,
One and
this is
L2.
1, here also 1. So that can be written as L11, no? L1.
Yes, ma'am.
Okay.
Yes, ma'am.
So you can write this as k squared. This whole term I can group it and write it as L1. Same way I can write this as L2. This is actually equivalent to m squared. Okay. Now I have to simplify this by removing the square on both sides. So if I do that, it will be K into L1, L2. Again, an important formula relating self-inductance, mutual inductance, and the coefficient of coupling. Okay, make a note of this also. So what is the formula for mutual inductance in terms of coefficient of coupling and inductances?
K into
into
root of
Li
L1,
by
L2.
And then it goes to
L1.
L1.
Okay. Have we made a note? Shall we proceed to the problem?
Ma'am,
What?
ma'am, if asked as a numerical, so the value of k will be given, or we need to find out.
Depends upon what problems you solve. I will solve the problem now, that time you'll understand. Okay.
Okay, ma'am.
Okay, with this, the theory part is over. We will solve problem. Just read the problem statement. What is given in the problem? Fine.
Ma'am, resistance equal to 50 ma'am, 150 ohms. Resistance of
Okay.
coil. Magnetic
A
flux.
coil is
Magnetic
there whose
flux.
resistance is, yes, magnetic flux is 0.1 milliweber. Then,
Number of turns equal to 500 ma'am.
so N is equal to 500. Then,
Resistance of galvanometer 450 ma'am.
okay, you are having one galvanometer connected in series with the coil, and the resistance of the galvanometer is 450 ohm. Then,
Magnetic flux of another coil 0.3 Weber ma'am, meter Weber.
that is not another coil, same coil only. Two fluxes there. Initial flux is 0.1 milliweber. The second nature of the flux is 0.3 milliweber.
Oh,
And the change is done in how much second?
0.1 ma'am.
0.1. And they have asked you to find out what the parameter.
Average induced EMF and average current ma'am.
So you need to
Value of
find
E
E
and
and I.
I.
So how can you solve this problem? You want to tell me.
Ma'am, n into d phi by
E equal
dt.
to N into d phi by dt ma'am.
So as per Faraday's law of electromagnetic induction, E is given by the formula N into d phi by dt. N is already known to you, that is
500.
500 number of turns. How will you solve for
0.3.
d phi by dt?
Phi 2
dt is
minus phi
given to
1 by
be,
t ma'am. Phi 2 minus
yes,
phi
this
1 by
is
t.
your phi 2 d phi na. So d phi is nothing but change in flux. So there are two fluxes that are given. One is 0.1 and the other one is 0.3. So you have to take the difference. So 0.3 minus 0.1. Okay. So this way, if you are doing, then what is the answer that you are getting? Induced EMF.
1.
1 ma'am.
All are getting
1.
1 volt. Are you
Yes
doing
ma'am.
calculation?
Yes, ma'am, or not?
Yes, ma'am.
Okay, so the answer for the EMF is 1 volt. Still, you need to find the current. Okay, current is as usual given by Ohm's law. So what is the formula?
I
V
equal
equals to
to
IR.
V by R.
I is equal to E by R.
E.
Okay, so E is 1. So what about resistance? There are two resistances that are involved. One is for the coil and the other one is for the galvanometer. So both you have to
And we
sum
need to add
because
it.
both are connected in series. So 150 plus 450. So what is the answer?
550. 1 by 550.
600. 1 by 600.
What is 1 by 600?
0.001 ma'am.
Okay, all I've got 0.00167.
Yes, ma'am.
Yes, ma'am.
All I've got
Yes
that.
ma'am. Yes ma'am.
0.67 into 10 raised to
So
minus.
this is one simple problem that might be asked in 4-mark question. Now you read this problem and tell me what they have asked here.
L equal to 100 centimeter ma'am.
What is L?
Length ma'am. Length of conductor.
The
Length of
conductor
conductor.
length L is equal to 100 into 10 to the power minus 2 meter. Then,
Flux density
Flux.
B equal to 1.5 ma'am.
so this is your P. Okay, then
Velocity equal to 30 ma'am.
this is V. Then what they have asked you to find?
Induced EMF.
EMF. EMF they have asked you. Okay, when the conductor is
Ma'am,
moving at what?
BLV.
PLV, ma'am.
BLV.
E
Theta is
equal to
90
equal to
BLV
60
sin
degree.
theta.
Okay, so
BLV sin theta.
BLV, yes, C is equal to
Sin theta.
BLV sin theta formula. Okay, they have asked you to calculate first when the rotation value is 0. Okay, theta is equal to 0 and theta is equal to 60. Two cases they have asked you to find. So first case you have to substitute E is equal to BLV sin 0. Okay, so what is the answer?
65 volt.
45. Second case, when theta is equal to 60.
ఇదే కావాలనా
See, Veeravardhan, from your place, so much bird noise is coming. Okay, what's the answer? Second case, when theta is equal to 60, what is the answer? Have you got 38.9711?
Yes, ma'am.
Yes,
38.9.
ma'am.
All the others in
Yes,
class
ma'am.
also, I don't want you
Yes,
people
ma'am.
to be
Yes, ma'am.
silent. I will not know whether you are solving or not.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so we will proceed to the next problem.
Yes, ma'am.
What about this problem? What are the things that are given in the problem?
Of conductor.
Same conductor again, L is given to be 10 into 10 to the power minus 2
Ma-
meter.
Magnetic field of strength H.
H 1000 ampere turn per meter.
Current
And they have, current I is equal to 60 ampere and they have asked you to find out what
B equal to mu naught mu R H ma'am.
mu naught mu r h.
Yes,
Where
ma'am.
is mu naught given? Mu r is it given?
Mu naught mu R
Area
is equal to 1 ma'am.
is given now. Have they asked you to
Yes, ma'am.
find the B? What have they
Yes,
asked you
ma'am.
to find?
Force
Don't
acting.
simply
Force,
say
ma'am.
yes, yes. Force, how can you use B formula? Veeravardhan. Force, what is the formula? Already I told you. This is
B
acting like a motor.
BIL sin theta ma'am.
Yes, BIL sin theta. Okay. Alright, so you are using VIL. Theta value is not given, so you are going to assume it as 0 as usual. L is directly known to you. I is also directly known to you. but B is not known to you. Okay, that is an X factor. So how will you determine B?
Mu naught H, ma'am.
Yes, they have indirectly specified H value, so that is why you are using mu naught H formula. Okay, mu r is not given, so relative permeability if it is not given means you have to use mu naught H formula only. So what is the answer that you are getting?
0.007, ma'am.
All are getting 0.00754 Newton.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. 0.007.
Okay. Now comes a different problem. What is given in the problem?
N equal to 480.
This n is equal to 480
L
turns. Then
L equal to 30.
L is equal to 30 centimeter. That is 0.3 meter. Then
Area. Area.
cross sectional area A is given. Then they have asked you to find out what
Inductance of the coil, ma'am.
inductance of the coil. And next
L.
thing,
L.
they have asked you to find L and D, that is self-induced EMF. And
Yes,
what is the
ma'am.
current that is specified?
4 ampere, ma'am.
4 ampere is reversed in how much second?
60 meter per second.
So how will you solve the problem? You have to tell me. First thing you need to find out L. What is the formula that you will use up?
L equal to
N
N
into D
square by
square.
S, ma'am.
Okay, n squared by s. Okay, so n is directly given, that is 480. You can substitute here. What about s?
S equal to mu L by mu naught
L by
mu
mu
r
naught mu r
mu
a,
r
but
a
mu r is not, that's an air core, so mu r will be equivalent to 1. Mu naught, you know what to substitute, 4 pi into 10 to the power
into
minus
10 to the
7.
power minus
Area
7.
is given 5 centimeters squared.
0.3.
L is also given directly, so find out the answer and tell me. Reluctance. And
0.47, ma'am.
that is reluctance.
L, ma'am.
L.
Yes, ma'am.
What is L?
Wait, ma'am.
Point 4, ma'am.
0.4 or 0.5 approximately.
0.5, ma'am.
Around 0.5 to it. 0.48 means approximated to 0.5.
Ma'am,
All have got the answer.
individual EMF equal to N L into di by dt.
Induced EMF, how will you calculate? L into
L into di by dt.
di by dt. So L just now we have calculated 0.4825, that you will substitute here. What about di by dt?
4 by
dt
6.
dt is 60 millisecond. What
Yes,
about
ma'am.
dA? They have given
Minus
4
4, ma'am.
ampere.
Minus 4. Minus 4.
4 ampere is reversed in 60 milliseconds. So initially the current will be 4 and it is reversed, so minus
Minus 4.
4. Okay.
Yes, ma'am.
So like this you have to write di.
Yes, ma'am.
Divided by dt is equal to 60 into 10 to the power minus 3. Okay. So that is how you got this 8 divided by 60 into 10 to the power minus 3. Remember, 4 ampere is reversed. Okay. Initially it will be 4 and it is reversed means negative sign you have to use. That way you will get 4 minus of minus 4. Okay. So tell me what is the answer for induced EMF?
Ma'am. 0.64, ma'am.
All have got 0.64?
0.6. Yes, ma'am.
Ma'am, 1 minute, ma'am.
Excuse me, ma'am.
The rest are solving the problem or simply you are sitting. I'm
Excuse me,
getting no
ma'am.
answer from others.
Ma'am,
Oh.
ma'am, please could you mark me present? I can't connect using my official mail ID.
This is Saumila. Oh, Yashwant.
Ma'am,
Rajeshri.
Rajashi.
Okay, man, you
176
solve the
Rajashi.
problem. All out of blue, you are telling that I have used unofficial SRM SD. You
Ma'am,
should be
not
present.
me.
Ma'am, I
First,
tried
first
to
you solve the
connect with
problem.
the
No, and there are so
official
many
ID
people
that
who
got
are
First
getting
you
disconnected.
solve the problem.
exited.
Yes, ma'am, got the answer.
All got the answer.
Ma'am, got the answer.
Yes, ma'am.
Yes,
Yes,
Point
ma'am.
dot 6433. And all of you understood how I got this 8 there?
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am. Yes,
Yeah.
ma'am.
One more problem. This problem. Try to solve the problem and tell me what is asked.
Ma'am, can you minimize that? We can't see whole question.
What?
We can't see whole question, ma'am.
I am not understanding what you are telling. Who is speaking?
Ma'am, can you minimize your screen because we cannot see whole question.
So, okay, it is enough for that. I don't want to show you the answer. That's why I am not showing full screen.
No, ma'am, after 1010, what is it?
Half the
Through a coil of 1010.
1010, yes.
You don't need that, bro.
You want to determine self-inductance. The given data all are visible only.
Okay.
0.6 milliamp Henry, ma'am. 0.6 millihenry.
Why Chinmay sir is coming all of a sudden and asking entry without official SRM SDID?
Ma'am, I got disconnected. I was
I am not
using
talking to
official
you.
ID, but
Don't
I got
confuse me.
disconnected and I couldn't join.
0.06, ma'am.
0.06, ma'am.
What is the formula that you have used?
L
What
equal to
L
N
equal to
into d
N
phi
d
by
phi
di.
by dt.
L is equal
Di.
to
d
And
phi
Into
by
d phi
N
by
into d phi
dt.
by di.
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 5 by DL.
so what is n 1000 ton? What is
1000 times,
5?
ma'am.
0.3 milliweber.
0.3 into 10 power minus.
Okay, let's check out the answer. All got 0.06.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
This
ma'am.
is one simple problem only.
Ma'am, I was not able to join from my assignment mail. I got disconnected, ma'am. Hello, ma'am.
Okay, okay. This problem we try to solve. Okay, okay, take on this one. That's only important. So take on the problem. Have you taken down? So what is the thing that is given in the problem? What are the given data?
We have to
Come on,
find
Ayyappa
N1,
should tell
N2,
me. Wait. The others you keep quiet. I'll point someone and I will ask answer. Okay. Okay, Ayyappa and Mayank should tell me what is the given data in the problem. Ayyappa, Mayank.
madam.
Number of turns is 250. Current.
Who is telling me this answer?
Ma'am, I'm reading question.
Mayank. Mayank and Ram Ayyappa, between you two, you have to define the various given data and you have to tell me what you need to find.
Yes, madam.
And Sai Preetham and Jay Praveen, your idea of joining class regularly, when will it be, man? Out of blue, one class you are attending. Jay Praveen and Sai Preetham. Jay Praveen and Sai Preetham. Whenever I ask Sai Preetham is telling here afterwards, I will be regular. You will be the one to suffer. They will detain you if you are having less attendance percentage. If you people are saying your mic is not working, nowadays you are to settle with online classes. You have to get it work. You cannot always say that my mic is not working, so I won't speak. What about Jay Praveen? How to maintain both in lab as well as theory. In case if you are having very less, then they will detain you. Then you won't be able to write the exam. They will ask you to pay a fine of 10,000 rupees and they will be allowing you to write the exam only in the next semester. So it is a waste. You make a note of that. I want everybody to be regular to all the classes. Again, I am telling you, in case if you are not able to maintain attendance 75% and above, you will be detained for the particular subject and you will be asked to pay a fine of 10,000 rupees. And they won't allow you to write the exam for this semester. You will be asked to write only in the next semester after you pay the fine. So waste of money, waste of time, and you will forget whatever things are taught and you won't be able to pick up the exam and clear it. Better be aware of it and attend classes regularly and maintain above 85% attendance at least to be safe. Simply you cannot skip classes. Now back to Mayank and Ramcharan Ayyappa. What is the given data, man?
N1.
N is 250. Then there are two coils actually. N1 is 250, they are telling. Current of 2 ampere flows in the coil. So I1 let us assume to be 2 ampere. Then you are to tell me the data or I am to assume data. I have given you some work. So accordingly you should tell me the answer. What are the other things that are given in the problem?
Phi is equal to 0.3.
Phi is equal to 0.3 milliweber. Then these are all for one coil. Then the next statement says when this current is reduced to 0. So initial current was 2, now it is reduced to 0 in how much second?
2 meter second.
2 milliseconds. Okay, and the voltage induced in the other coil, that means mutually induced EMF or a self-induced EMF?
Mutually, ma'am.
Mutually induced EMF. So this is your mutually induced EMF. Okay, not self-induced EMF. There are two coils actually. The number of the coils in the primary side is turns in the first coil is 250, current is 2, because of which the flux that is set up is 0.3 milliweber, and after some 2 millisecond it is reduced to 0, and the mutually induced EMF 63.75. And what else is given?
K is given, ma'am.
K is given to be what
0.75.
value? Coefficient of coupling K is given to be 0.75, and they've asked you to find out what data?
Self-inductance,
L1, L2,
mutual
and M.
inductance, number of turns in second coil.
So L1 you need to find, L2 you need to find for the two coils. Then
Number of turns in second coil.
number of turns in primary coil they have given, but they have asked you to find out N2, and M also they have asked. So how will you possibly solve the problem?
Ma'am, for L1,
Think
can
of
we use N
somewhere.
into d phi by di?
How can you find L1? Easy to find or not easy to find? What is the formula for L1?
N into d phi by di.
And d5 by d.
Okay, so L is given by N into d phi by dt. That is a formula. That is L1 means 1 you have to indicate. So N1 is directly given, that is 250. What about dt and d phi? Di. Okay, not dt. Because habit
Di
I am
is
telling
2, no,
dt.
ma'am. 2 ampere.
D phi
will be
is 0.3 into 10 to the power minus
0.3 into
3
10 to the power
minus
minus 3
0.
Weber.
Okay, then current is reduced from 2 to 0. Okay, so
Yes,
2
ma'am,
minus
that
0,
is 2.
I think so. Let us solve for that L1. So as you are seeing, so they have solved for N1 using the formula. And what is the answer that you are getting?
0.03.
I is reduced from 2 minus 0.
0.03.
Okay, this is 5. Initial flux. 0.0375 you got for L1.
Yes, ma'am.
Wait, calculating, ma'am.
Yes, ma'am.
Okay, next
So,
L1 is found out, but you still don't know L2. So how will you solve for L2? You don't know N2, that is not known. Okay, you don't know Di2, that is also not
ma'am,
known. You don't know D5 2. So how will you
ma'am, can
solve
we
for
use
L2?
M is equal to K into root L1 into L2 to find L2?
Yes, M is equal to K into L1, L2 you can use, because you know the value of L1. K is given directly in the problem. Still you
We
don't know
don't know
what is
M, ma'am.
M.
M.
Yes,
So
And
ma'am.
we
how will
can
you
calculate
find
number.
M? M is given, no?
No, ma'am.
No,
What is
ma'am.
M?
We
That
find
is
out
given
M, ma'am.
directly. Mutually induced EMF is given to be equal to what value?
No, ma'am. Voltage
We
induced
can
EMF
calculate.
given, ma'am.
By
E2 given,
63
ma'am.
point.
and di by dt we can find.
Mutually induced EMF is 63.75. Okay, so use the formula and find out L2. M is equal to K into square root of L1, L2. Okay, M squared is equal to K squared L1, L2. I want L2. L2 is equal to M squared divided by K squared into L1. All the data is given in the problem. Substitute and find L2.
Ma'am, is the answer 0.192?
What's the answer?
0.192.
Your voice is not complete. Okay, your voice is breaking or cracking.
I'm initially
Ma'am,
0.2.
is the answer 0.192, ma'am, of L2?
Are you able to see the screen that I'm presenting?
No, ma'am. It is,
No.
Yes, ma'am.
ma'am, it is
You're able to
showing till
see?
only given.
Really, I'm not able to see. Guess you what answer you are giving. screen you are able to see, no?
Ma'am, only given is visible.
Really, Yashwant, I am not getting your answer. Your voice is cracking.
Okay, ma'am.
Ma'am,
What?
can
I
you
think from my side net problem. See, whenever you are not answering, please keep your mic muted. I am hearing so much interference.
ma'am, can you please zoom it?
Type in the chat box. Yashwant, also keep your mic mute because your voice is cracking.
Excuse me, ma'am.
I think from
Excuse
my
me,
side
ma'am.
net
Excuse me,
problem,
ma'am.
I think.
0.192.
Yes, ma'am. 0.19.
Excuse me, ma'am.
Yes, ma'am.
I think
0.192.
from my side
Okay,
net problem. Whatever answers you are giving, I am not able to get it. It is delayed.
No, it is
Excuse
not
me, ma'am.
visible on screen.
Ma'am, 0.19.
Ma'am, please zoom that.
I am not zooming in the answer part. You have to solve it. Every time if I show the answer and the way to solve, then you will not think.
No, ma'am. At
Excuse
that
me, ma'am.
time, the question was not visible.
You got the answer 0.192, L2.
Yes, ma'am.
Yes, yes.
Yes, ma'am.
What about the
Yes,
rest in
ma'am.
class?
Ma'am, we need to find also, no, ma'am, N2.
Really, I think there is a net problem from my side. Because of which I am not able to hear all your people's proper voice.
Ma'am, but your voice
But
is
anyway,
clear, ma'am.
really some small crack is there, delay is there. The screen is noticeable.
Ma'am, can you zoom in the question?
There's a small problem from my net. Now are you able to see the screen?
No, ma'am.
No,
Are you
ma'am.
able to hear us? Ma'am, are you able to hear us? Has ma'am left the meeting?
Yes.
Yes.
Is the class still going on?
Yes, ma'am has come back. Ma'am, your mic is on mute.
In case if you're not able to connect to the system, you try to solve the problem now. You are able to see the screen that I'm presenting.
No, ma'am.
Yes
No,
or no?
ma'am.
No,
No,
ma'am.
ma'am.
Try to solve, complete the problem, okay? You are able to see the screen means try to complete the problem. In other system, I'll try to connect.
Ma'am, also your voice is not clear, ma'am.
Yes, ma'am. Your voice is not clear.
We can see the screen.
Now you are able to hear me, yeah?
Yes, ma'am.
Yes, ma'am.
You solve the problem. L2 is 192. You are able to see the
0.192.
screen also.
Ma'am.
You are able to check out the screen.
Yes, yes.
Okay, next two more things they have asked in the problem. Okay, you have found out what is L1. You have found out what is L2. Okay, now you need to find out mutual inductance in the number of turns in the second coil. Okay, so how will you solve for these two?
M equal to K into root of L1 L2.
What M, like you are having the formula for L. One formula is there for L, no? What is the formula is there for L? One is
N into
N
d5
square
by dx.
divided by S. What is the other formula?
N into d5 by
DI.
N into d5 by dt. But one more formula for Faraday's law of electromagnetic induction is that is self-induced EMF. What is the formula? L into di
d5
by
by
dt.
dt.
Na?
Yes, ma'am.
So if you are replacing this L by M factor, okay, that will become mutually induced EMF also. Okay, so you know what is the mutually induced EMF? That is, I think, 63.75 volts. Okay, and the unknown factor is M that you want to find out. Di by dt is also known to you. Di is given to be 2 ampere. Dt is 2 millisecond. Okay, you can solve this M by using this formula. So solve it and tell me what is the answer.
M 63.75 millihenry, ma'am.
Yes, my ma'am was given, na ma'am, in the question.
No, ma'am.
So find out M.
Given.
You have any doubt?
No, ma'am.
What is M?
63.75.
63.75 millihenry.
Same. M is equal to 63.75 millihenry. You got a?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay, so mutual inductance is over. Next one, final parameter that you want to find out is the number of turns in the secondary coil you have to find. Okay. So the number of turns in the secondary coil, how will you find that?
E equal to N2 into di by
E is equal
dt.
to N2 into
N2 into
d5 divided by dt.
by
You are saying that formula you want to use.
No, ma'am, but quantities are not there, no?
Yes, that formula you can use. Okay, so that formula only is being used, but dt is known to you. Okay, N2 is unknown, and the mutually induced EMF is known to you. That is 63.75, but still you don't know what is phi 2. So that is given by k into phi 1, because in the problem they have given phi 1 only. They have not given phi 2. How much flux is linking with the secondary coil is not given. But the coefficient of coupling is given. Okay, so use that and find out what is the number of turns N2. You understood the concept or not? See, they have given K is equal to 0.75, that is given. And they have asked you to find out,
wow.
they have asked you to find out N2. So you are going to use EM2, okay, EM, that is given by d phi 2 divided by dt. dt is also given, that is 2 millisecond. N2 is the unknown factor that you are trying to find out. EM is 63.75. N2 is X factor that you are trying to find out, but phi 2 is also not given. But they have given K. Okay, so using phi 2 is equal to K into phi 1, you can find out N2. So find out N2. Phi 1 is known to you, that is 0.3 into 10 to the power minus 3 Weber. Multiply that with the coefficient of coupling, you will be getting how much amount of flux is linking with the secondary coil. Solve for N2 and tell me the answer.
Five hundred.
All got the answer for N2?
500.
What is the answer for N2?
500 and
500 and you got the answer 567. 67.
Ma'am, I got 66, ma'am. I think.
You have did some mistake in that case. 567 is the answer. This one is 63.75. N2 is unknown factor that you don't know. This one is k into 5.1. So 0.75 into 0.3 into 10 to the power minus 3 because it is in milliweber. dt is 2 milliseconds. So 2 into 10 to the power minus 3. So you will be getting 567. All have got the answer 567.
$64, ma'am. 564.
Okay, 564 is also well and good only. Approximate to 560.
Yes, ma'am. Me too. 564, ma'am.
What, Shainesh?
For me
564,
also
ma'am.
564, ma'am.
Okay, around 564 if you got, no problem.
Yes, ma'am.
What
Yes,
about the
ma'am.
resting class? Have you got this answer? This is the last problem that I will solve.
Yes, ma'am,
I
got
will move
now.
on to the theory part now.
Yes, ma'am.
Ma'am, I'm getting
Yes, ma'am. Got.
566 only, ma'am.
Okay, no problem. 566 is also good. Okay.
Okay, ma'am.
So with this, I'm closing off this magnetic circuits and inductance sort of problem. Okay. Next, we will move on to theory again. So already in lab class, I told you what are the constructional details of a DC machine, how you can classify machines, and what is the working principle of motor and generator, all was discussed. Today's class, I will teach you how you can classify these DC machines. Okay. Wait, let the page load.
Hello, ma'am. Hello, ma'am. Hello, ma'am.
I think so, ma'am.
Ma'am
Has
got
left the
disconnected
meeting.
again.
Yes, yes. Yes.
are able to see the screen that I'm showing?
No, ma'am.
Yes, ma'am. Yes, ma'am, but the font is very small, ma'am.
Yes, ma'am.
Already we have discussed this principle of operation and all in the earlier class. These are the magnets that you are having, which will be setting up lines like
Voice
this.
is not clear, ma'am.
In which you are
Your voice is not clear.
rotating.
Voice is not clear, sir.
Okay, which will be inducing an EMF, which is dynamically induced as per Faraday's law of electromagnetic induction.
Ma'am, again voice is not clear, ma'am.
See, my net connection is very slow. I'm going to adjust for next 20 minutes or okay. I'm trying to reconnect in both the systems, but one system is very slow. And this is how alternating nature of current is generated in the armature. Okay, when this is made to rotate in the flux lines, depending upon the position that it takes, the EMF will be either maximum or it will be zero at different positions. So this is how an alternating current is generated at this point. By using a rectifier, we are going to convert that into pulsating DC. All these things we have discussed. Okay. Constructional details also we will discuss. What are the various constructional parts that you are having in the DC machine? Will the same machine be used as a motor and generator as possible?
Ma'am, your voice is breaking, ma'am.
Ma'am, we can't hear anything.
Yes, ma'am, we can't hear
We
anything.
can't hear only, ma'am.
I got we'll try to connect in another
Hello.
sorry, but my system is showing full strength connect, but problem is that try to sort out. Some problems there in Google Meet itself. Other pages are getting collected. I'm not able to connect it in 5 minutes. We wind up the class. We can do this class rather than make it practice. Okay, we'll wind up the class for today. I think it's better for you and me rather than wasting time. Are you able to hear me now properly?
No, ma'am.
No, ma'am.
There is still noise.
Are you able to see the screen?
Yes, ma'am.
No, ma'am.
Ma'am left the meeting.
Okay, so we shall also leave the meeting now.
Yeah, I guess.
I think
You didn't get that notification.
We'll wait till 10:55.
Is the
Then
class
we'll also
over?
leave.
yeah.
I just got reconnected, man. I got connected after class was over, man. What the heck?
You class didn't get over. Mom got disconnected.
Oh,
Yeah, but ma'am told that you can also wind up now.
Rajshri, can you call ma'am?
You know we'll wind up. हो गया तो हो गया ना.
she isn't
I mean,
picking
like,
up anyway.
Yeah, we have to ask.
चलो भाई
चलो बाय.
वैसे भी ऑटोमेटिक कर देते हैं बोल देंगे आप डिस्कनेक्ट हो गए